My name is Graphics. Today we want to solve this problem in Laplace transform. Now I said use the inverse Laplace transform to solve this. So what you do is the solution. What you do is you say we should solve this using inverse Laplace transform of x plus 1 all over what? S squared plus 2x plus 10. Right? This is what we're having here. Now you need to know very well that if you look at this equation here, we call it a trinomial. It cannot be factorized, right? So we are going to use completing the square method to factorize. Now let's go back the memory lane. So what we'll do first is the Laplace inverse of this is s plus 1 all over. Now see what will happen. If I have s squared plus 2s plus 10, I'm going to write s squared plus 2x, right? Now I'm going to look for the half of the quotient of x here. The quotient of x here is 2, right? So the half of 2, and that will give us what? 1, right? So we'll now square it. So we'll be having 1 square, and 1 square is 1, Abi. So this will now be plus 1, you minus 1, then you put plus 10. Is that taken? You look for the quotient of the half of the quotient of x, which is 2 divided by 2, or 2 multiplied by 1 over 2. And by the time you do that, you'll be having what? 1 square. Is that taken now? So 1 square is 1. So you add 1 to this and you subtract 1. So plus 1 minus 1 is 0. So it's as if you have not done anything. So now what you do here is this will now give me s squared plus 2x plus 1. You put it in bracket. Then minus 1 plus 10 will give you what? Plus 9. Now s squared plus 2x will give is what? X plus 1 all squared. Then we have what? Plus 9. Is that taken? Because if you have s plus 1 times s plus 1, it's s plus 1 square, right? So s times s is x squared. X times 1 is what? X. 1 times x is x. 1 times 1 is what? 1. So we're having s squared plus 2x plus 1, which is what we have here. So that is what we're putting here. So this is what now will come and place here. So we're having s plus 1 all squared plus 9. So this is what we're having. Is that okay now? So what you do here is this. I can break this into 2. I can say that the Laplace inverse of the Laplace inverse of 1 all over what? S plus 9 multiplied by the Laplace inverse of x plus 1 all over x plus 1 all square plus what? 9, which is 3 square. So I can put it this way. Is that okay? Because if I do this, I will surely have something like it, because in this place here now we have the quotient of what? Of 1 here. So if you Laplace this, right, if you recall, let me take you down the memory lane. If I have e raised to the power of what? A minus at to give me 1 all over x plus what? Plus a, right? So that means if I have e raised to the power what? Minus 90, it will give me 1 all over what? S plus what? Plus 9. Is that taken now? So if I'm going backward, it means I am using Laplace inverse for this. So Laplace inverse of this will give me this. Laplace inverse of this will give me this. So I'm going to write this as saying that what? From here now I'll have e raised to the power of what? Minus 90. Is that taken? E raised to the power what? Minus 90. And this now, once you have the same, recall also, if you have x all over what? s all over s squared plus what? A squared. It will give you cos AT, right? So now if you now have x plus 1 all over s plus 1 all square plus 3 square, and that will give me what? Cos 3t. Is that okay now? Because once here are the same, you use cos, and whatever you have here, that's what you have in here. So this will now give me cos 3t, right? So what I'm trying to say is that what? The inverse Laplace of this, the inverse Laplace of s plus 1 all over s plus 1 all square plus 9 will give me this as my answer. So thank you for watching.